All right, let's go through some review problems for this topic 3 test coming up. So number 1 and 2, we have to graph the polynomial function, estimate the zeros and the turning points of the graph. So I'm going to zoom into this graph. Here's what I would do. Grab your graphing calculator, go ahead and graph it on your graphing calculator. From there, you should be able to estimate the zeros. So if we just kind of make a list the zeros of our function, we can see there's one at -3, -2, -1, 1, and 3. We can go ahead and plot those points on our graph. So we have -3, -2, -1, +1, and +3. And then let's estimate the turning points. So you can estimate turning points. Where are those happening? If you hit the trace feature on your calculator, you can just scroll through and see where it starts turning between like an increasing and a decreasing interval. So let's list off where we see those are happening from left to right. The turning points, I see one happening at about 2.6. I'm going to keep going. Now I'm decreasing on my graph and about, that was a negative, by the way. There's another one at about a -1.5. I'm just tracing along to the right. I can see it turns again at about a 0.3, +0.3. We've got another one at about 2.4. So what we did with these turning points in class is we just kind of sketched in vertical lines. So -2.6 is about here. Then we have one at -1.5, 0.3, and a 2.4. If we look at our graph, we can see what the end behaviors are. And the last bit of information, the end behavior, just by graphing it, we can see we are going down on the left and up on the right. We also could gather that from our leading term here. Positive leading coefficient is going to approach positive infinity on the right, and an odd degree is going to do the opposite of that. The one other piece of information that would be helpful is to identify the Y-intercept. The Y-intercept, if you plug in a 0 for all of these x's, you're left with that term, and that's how you find a Y-intercept, is by plugging in those zeros. So let's just make a note. We know that our Y-intercept is at +18. So when we sketch the graph, let's go ahead and put that Y-intercept on there, just so we have that one point to also shoot for, as well as our x-intercepts. Now 18 is not on this graph, but we could count 1, 2, 3, 4, 5, 6. Maybe I'll count by threes, and I'll put my y-intercept up there, and I'll just make a note that's 18. All right, so when we sketch in our graph, again, this is a sketch. Let's just make sure we have those end behaviors. We go through our intercepts, and we are turning when we hit those vertical lines. So we're going to kind of head this way. Oh, I got to turn, hit my x-intercept. I got to turn, hit my x-intercept. I have to go really high to get that 18. And I haven't hit a turning point yet. So, oh, there's my turning point. Now I'll go down, hit a turning point, and something like that. That's a sketch of the graph. All right, so moving on to the next one, we'll just follow that same idea. Let's go ahead and put this into our graphing calculator. We can estimate the zeros, the turning points, and we can get our y-intercept as well. So the zeros of the function, we're crossing the x-intercept at a -4, a -2, a +2, and a +3. Now, one thing to keep in mind, if you graph this function and you can't see the whole thing, Start modifying your window, the X and Y axes. What do you want those to count by so that you can capture the whole thing? On this one, my window, the X minimum is -6, the X maximum is 6. The Y minimum is -40, the Y maximum is +55. So I had to create that window, and it was trial and error until I could see the whole thing. All right, so let's plot those intercepts. We have -4, -2, +2, +3. All right, now I'm going to identify the turning points. I'm going to go ahead and use the trace feature. So I'm going to trace, if you guys hit trace on your calculator, I just had to trace over to the left side. So I'm decreasing till about X is maybe like a -3, right around a -3. And then I'm going to keep tracing, and my next one is turning around about a 0. And these are X values. When is it turning from increasing to decreasing and vice versa? My next one is happening at about a 2.5. So I'm going to draw in those vertical lines just to have as guides for the graphing. Here's my -3. Here's my 0. Oops, here's my 2.5. I can see that the end behavior is going up on each side of our graph. So let's go ahead and draw that in. Oh, let's not forget our y-intercept. The y-intercept, if you plug in a 0 for all your x's, our y-intercept is at 0, 48. So I'll just want to make a note. Let's see, 1, 2, 3, 4, 5, 6. I'm going to make this one 48, and I will count by 8s to get that to 48. All right, so now when you sketch in your function, it's going to come down, hit a turning point, go back up. I've got to hit my y-intercept, which also I'm turning at that same spot, and I'm going to go down, catch that x-intercept, turn, and go back up. And that's a sketch of our function. All right, let's take a look at our next problem. Number 3, a polynomial function has the following end behavior. As x approaches -infinity, f of x approaches infinity. So let's sketch out what this is. Remember, on your graph, infinity is to the right, -infinity is to the left. So that when they say as x approaches -infinity, that is the left side of your graph. And f of x, remember, that's just the same thing as y. Y is approaching +infinity, so our graph is going up on the left side. Then as x approaches infinity, that's the right side of our graph, f of x, y, is approaching -infinity. Okay, so what type of degree and leading coefficient would give us this end behavior? So we always talked about determine the right side of your graph first, and that comes from the leading coefficient. So the leading coefficient caused this to go down on the right side, so our leading coefficient must be negative. And then the left side of our graph, the degree tells us what's happening on the left side. It's either going to be the same as the right, or it's going to be the opposite as the right. Because we went down on the right and we're going up on the left, that is the opposite. That just means that our degree is odd. All right, moving on. Number 4. After X hours of hiking, Sadie's elevation is P of X equals -x cubed plus 11x squared minus 34x plus 24 in meters. After how many hours will Sadie's elevation be 18 meters below sea level? What do the X and Y intercepts of the graph mean in this context? All right, so if we take a look at what this graph looks like, I'm going to do a sketch, but my sketch is coming from my graphing calculator. The y-intercept, I already know is going to be at a +24. So up at a +24, actually, I'm going to draw in a few more details of this graph. Okay, so here's my little sketch of the graph. I graphed on my calculator, and I know the y-intercept is positive 24, which I know that just from the equation right here. The x-intercepts appear to be at 1, 4, and 6. And then the question is asking, after how many hours will Sadie's elevation be 18 meters below sea level? So I just made a note of where negative 18 was if we are below sea level. So this would be sea level, which has an elevation of 0, 24 meters above. Here's your negative 18. So let's just identify the few things. They said, what do the x and y intercepts of the graph represent? So the y-intercept is at 24. That is the starting elevation. Before any time has passed, she is at 24 meters above sea level. The x-intercepts, we have 3 of them. There's 1, 4, and 6. Those represent the hours when she's at 0 meters for elevation. So she's hiking, she's starting 24 meters above. Time passes. At 1 hour, she is at sea level, 0 meters. Then she's below sea level in her elevation. At 4 hours, she's back to 0 meters elevation. She gets a little bit higher. Then at 6 hours, she's at 0 meters elevation. And then her elevation keeps dropping. So that's what the x and the y intercepts represent. Question is, after how many hours will Sadie's elevation be 18 meters below sea level? So here's that 18 meters. When is she going to be here? And I can see right there is when that's going to happen. So what I did on my calculator is I graphed a second line in my y2. I just said y2 equals negative 18 to get that horizontal line. And then I was able to, trace along and find that intersection point. And I can see that that happens when x is a 7. X is our number of hours. So after 7 hours, who is this? Sadie will be 18 meters below sea level. Okay, let's take a look at the next problem. Fill in the blanks based on the graph to the right. F is positive on an interval, negative on an interval, increasing, decreasing. So positive means that we are above the x-axis. So here's our x-axis. I can see that we are above the x-axis. Here, I'll do a little bit of highlighting. We are above the x-axis here. Well, that wasn't very dark. And here. So what are those intervals? So this one on the left would continue forever. So that's heading toward negative infinity. So that interval is negative infinity to right here, negative 2. So negative infinity to negative 2 is that first interval. The next one is going to be from negative 1 to this point right here, which has an x value of 0.5. So from negative 1 to 0.5, our function is positive. It's above the x-axis. So we're going to say from negative 1 to 0.5. Okay, intervals where our function is negative, that's going to be below the x-axis. So let me highlight that in a different color. We're below the x-axis here, and we're below the x-axis the rest of that way, which will continue forever. So our first interval from negative 2 to negative 1, we are below the x-axis. So our function is negative. And then right here from that 0.5, continuing forever that direction. So from 0.5 to infinity, we are below the x-axis. All right, so that took care of our negative. Now let's get our positive and negative intervals. Now let's talk about increasing and decreasing. So we are increasing from left to right. It's kind of like you're going up a hill. So if we look at our graph, we are increasing right here. That's the only spot we're increasing, that one interval. What are the x values right there? Those x values are a negative 1.56. So from negative 1.56 to this right here, the x is a negative 0.107. I don't feel like I have a lot of space to write that. Okay, so that's our increasing interval. Now decreasing left to right, I'll highlight in another color. If we're decreasing, here's where we're decreasing there, and we're decreasing here. So we have those two intervals. So we're decreasing starting from this direction, so that's our negative infinity, all the way up to that turning point right here where the x was a negative 1.56. And then we are picking up our decreasing right here where our x was a negative 0. This number is giving me problems. Negative 0.107. And then because it continues forever, all the way to positive infinity.